Great. Thank you for joining us today. My name is Nicole Rock. I'm an innovation specialist at the Good Food Institute India. For those of you who have joined us for the first time, the Good Food Institute is an international non-profit organization that works to advance the markets for plant-based protein, cultivated meat and dairy, and fermentation for enabling meat, dairy, egg, and seafood replacements. At GFI India, we're laser focused on building the enabling ecosystem for alternative protein. One of the ways we do this is through the GFI Ideas India community. The community brings together innovators who are transforming our food systems by creating or expanding access to the smart protein sector in India. We offer entrepreneurs, industry professionals, researchers, and service providers like yourselves the opportunity to connect with each other and share advice and resources to help you create a good food business. If you have any questions, concerns, comments, or suggestions, please feel free to contact us. I will be sharing our contact details in the webinar chat box shortly. This week, we have GFI India's very own science and technology specialist, Siddharth Bhide, sharing the science behind the development of plant-based dairy products. Siddharth holds a master's degree in food science from Rutgers University and a bachelor's degree in food technology from Osmania University in Hyderabad. Prior to joining GFI, Siddharth worked as a food scientist at Just in San Francisco and was a key contributor to formulating and manufacturing the Just egg, a plant protein-based egg. In addition to that, Siddharth has been a part of multiple research and development and food safety internships with General Mills in the US and Rutgers Food Incubation Center in the US, as well as Nestle in India. And with that, I will hand it over to Siddharth to begin this week's webinar.
Thank you, everyone. Thank you, Nicole, and thank you, everyone, for attending today's webinar. Give me 1 second. I'm trying to share my screen. Okay, perfect. So hi, everyone again. Welcome to the Good Food Institute's webinar on plant-based dairy. I'm very glad to be presenting today on this topic and the various aspects that one needs to understand while creating these products. Before we start, I would like to acknowledge the work and support of my co-authors on this webinar, Miranda Grizio and MJ Kinney. This webinar will be helpful to a variety of stakeholders, to businesses and entrepreneurs who are involved or looking to get involved in the plant-based dairy market, to technical specialists such as researchers, food scientists, and engineers who would like more scientific information on plant-based dairy, which will help formulate and scale up plant-based dairy products, to investors who would like to understand where the market is at for plant-based dairy and the projections, to students who wish to learn more about this segment or pursue research in this segment, and to consumers who are interested in consuming plant-based dairy products. The agenda for the webinar today will be starting off with discussing the market for plant-based dairy around the globe and the market growth over the years. We'll then be talking about traditional milk, which we'll be referring to as legacy milk in this presentation, its functionality, nutrition, processing methods, and these will serve as a basis to then explore plant-based dairy products. We'll then be doing a deep dive on plant-based dairy, focusing on plant-based milk, as it is the most popular plant-based dairy product and also forms the base to creating other plant-based dairy products. We'll then be moving on to sources of plant-based milks, the process flows to create plant-based milks, and regulations around these products in various geographies. Then we'll be talking about a few plant-based dairy products out in the market across the globe and understanding them from a product development perspective. We'll be discussing a new field of products that is coming up, which is a hybrid between plant-based and cellular agriculture. And we'll be ending the webinar with discussing specific white space opportunities from technical and business perspective in this segment across various geographies around the globe. So before we go into details of how plant-based dairy is made, a key point which I would like to highlight is that consumers make their purchases based on 3 things primarily: taste, price, and convenience. So these 3 aspects form the key to any product or product category success. So it is imperative that we need to make plant-based dairy products taste similar or better, price similar or lower, and make them have the same convenience, the same functionality as traditional animal plant-based dairy products for them to succeed. So please keep this in your mind space as we walk through all the other slides. Let's start off with the global and regional market for plant-based dairy with a focus on plant-based milk and understand why it is a good time to be in this segment. As seen in the graph on the screen, global market for plant-based milk is growing, and in 2018, the global retail sales of plant-based milk totaled $17.4 billion. The 10-year compound annual growth rate was positive 10%, and this represents a growing market with a lot of potential. By volume, plant-based milk now makes up 7% of the global milk market. And of the global plant-based milk market, Asia Pacific has the highest share at 66%, followed by North America at 16% and Western Europe at 11%. Since this chart talks about cumulative global plant-based milk sales, it is important to point out that traditionally, sales of plant-based milks were made of soy milk, but in 2012, non-soy beverages overtook soy for the majority share of plant-based milk market. Such alternatives include milk made from sources like almonds, like cashews, coconuts, hemp, oats, etc. Starting off with the Asia Pacific region, uh, because it had the highest share of plant-based milks. In 2018, sales of plant-based milks in APAC region totaled $11.1 billion. The region's top plant-based milk consuming countries rank among the global leaders in per capita consumption and are supported by high regional rates of lactose intolerance and price parity compared to traditional animal-based milk. China leads in plant-based milk with 73% of plant-based milk sales by value and 71% by volume, followed by Japan and Thailand. Focusing on China a little, China's long history of soy milk as a staple in the diet has allowed China to become a leader in the plant-based dairy early on, both regionally and globally. However, the demand has waned as consumer preferences have shifted in the recent years. Since 2013, the per capita volume has declined by a cumulative 20% and offset growth from elsewhere in the region. But what's positive is that China's volume contraction moderated in 2018, and we anticipate further improvement as companies including Wanfont, Vitasoy, and Danone come out with more innovations in this segment in the APAC region. Moving to Western Europe, the regional plant-based milk market remains robust. Over the past 5 years, per capita volume has grown at a compound annual growth rate of positive 10.5%. Per capita consumption levels vary widely, from a high of 7.4 liters in Spain, the region's share leader, 24% by value and 32% by volume, to just 1.4 liters in Italy. Like China, Spain has had a head start in plant-based milks too, compared to other countries in this region. This is due to the country's long use of horchata, which is a traditional plant-based drink dating back to the 13th century and is made from tiger nuts. Horchata remains an important part of Spain's culture, although plant-based milks made from soy and other crops are equally or more popular now. Horchata makes up 15% of the plant-based milk market currently in Spain. Spain's culturally entrenched horchata and China's long use of soy milk earlier points to the fact that plant-based milks have been culturally entrenched for a long time now in a lot of countries, and that is why it is leading to their widespread acceptance and usage. Spain's leading position in plant-based milk segment is also because Spain has one of the highest levels of dairy intolerance in Europe, and thus consumers prefer plant-based options in Spain. The plant-based dairy segment across Europe is growing as a lot of companies are innovating in this segment. And talking about companies, Danone is the market leader. Danone's 28% value share is more than 4 times that of the next largest competitor. Danone's portfolio is comprised of the mainstream Alpro, which is Europe's leading brand, and Provamil in the natural channels. Alpro has produced soy milk since the 1980s and was the first to launch non-soy milk alternatives. Moving to Latin America now, in 2018, the sales of plant-based milks totaled $670 million, but still comprised of only a small 2.2% volume share of Latin America's total milk market, and that is why we see ample room for growth. Brazil was initially the leader in the plant-based milk market. But over the last few years, the Brazilian market has been pressured by economic weaknesses, increasing concerns about transgenic and genetically modified soybeans, short shelf life, and fragmented supply chain. Because of this, in 2018, Mexico surpassed Brazil to become the largest Latin American plant-based milk market. Mexico's annual plant-based milk sales stand at $200 million and make up regional shares of 30% in both value and in volume. In terms of industry, Coca-Cola is Latin America's plant-based milk leader with $310 million in revenue, following the 2017 deal for Addis. Founded in 1988 in Argentina, the Addis brand holds a commanding 46% value share of Latin America's plant-based milk market and more than 5 times the largest branded competitor, which is Danone's Silk at 7.3%. Other multinationals like Danone, Nestle, General Mills are also making strategic investments in plant-based dairy companies to increase their presence across Latin America. Even in the United States, the value share of plant-based milk is over 13% and the volume share is over 8% of total United States milk market and is growing every year. This shows there is a tremendous opportunity to grow further, increasing the volume share and at the same time bettering the economics of scale. Here is an interesting graph published by Spins Retail and GFI, which looks at plant-based milk sales by product type in the US. Almond milk, as you can see, is the category leader with $1.3 billion in sales and continues to increase. Oat milk reached $84 million in sales and is the fastest growing plant-based milk. Dollar sales of oat milk grew 686% in the past year and 1,946% over the past 2 years. Oat milk's popularity is soaring as coffee shops learn about the excellent foaming properties of oat milk, which allows baristas to make high-quality plant-based cappuccinos and other coffee house beverages. Consumers who use oat milk as a beverage also appreciate oat milk's thicker, creamier texture compared to other popular plant-based milk options in the market. Pea milk has experienced a recent resurgence in the last few years and is experiencing a high growth too. The other categories of milk which are upcoming include hemp, flax, and walnut. Moving to India, GFI is working towards getting similar statistics of the market size of plant-based dairy and the past and the projected market growth over the years. So please stay tuned as we'll have some results in the coming months. Having said this, we have been seeing a lot of growth in the plant-based dairy segment over the past few years. We had Epigamia on the GFI India community showcasing their coconut milk yogurt a couple of weeks back, and we also had GoodMylk talking about their journey in creating plant-based dairy products. India is the largest producer of milk in the world with a very dairy-heavy diet, followed by both the vegetarians and non-vegetarians. But in addition to the reasons why plant-based dairy products are important, and for the reasons why GFI exists, for improving human health, promoting animal welfare, reducing environmental damage, and reducing global poverty, in India, there has been a growing awareness around the health issues and contamination when it comes to cow's milk. All this put together, people in India are demanding cleaner products which promote health, sustainability, welfare, and transparency, all of which can be delivered via plant-based dairy. Okay, so now that we know that the plant-based milk is gaining traction across the globe, let's understand the consumers and their mindset when they are buying these products. According to a report published by Wells Fargo Securities on plant-based foods, in the countries that lead in plant-based milk purchases, most households that buy plant-based milk are also buying the animal legacy milk. In the US, it is 88% of the households, and in Brazil, it is 96%. So we are talking about a mainstream phenomenon here where plant-based milks are no longer confined to vegan households. Factors that could be driving this trend include perceptions that plant-derived products offer superior health benefits, offer comparatively cleaner labels, and the perceptions of negative environmental impacts of traditional animal-based products. In another study conducted by Fonalytics that investigated which plant-based products were the most popular amongst flexitarians or omnivores in the United States, plant-based milk came out on top, with 51% of omnivores purchasing it at least some point of time. The next most popular categories for omnivores were burgers at 34% and other dairy at 32%, which doesn't include cheese as it is listed as a separate category in the study, but does include products like plant-based creamers and yogurts. When it came to the vegetarian or vegan population, to the right side of your screen, burgers came out at the top category as the top category, with 67% of vegetarians or vegans purchasing them at least some point of time, followed by milk and tofu. An interesting thing to note here is that the omnivore population, as seen even in the study and around the globe, is significantly higher than vegetarian or vegan population around the globe. Hence, alternative protein products opportunity is much higher with omnivores or flexitarians. Even Impossible Foods has reported that 9 out of 10 people who eat their products are regular animal meat eaters. So two key conclusions for this segment on plant-based dairy market is that there is a huge and a growing market across geographies for plant-based dairy. And second, alternative protein products, including plant-based milk and dairy, are no longer a niche trend, and the market is being driven by omnivores or flexitarians. Now let's move on to the technical segment of this presentation. And before we look at plant-based milks, let's first review some information on traditional animal milk, or legacy milk as we call it. We can then use this information as a basis for constructing our plant-based milk. Starting with the definition, a product must meet certain requirements to be labeled as milk, and these requirements vary from country to country. In the US, the legal definition of milk is defined in the Code of Federal Regulations. Milk is the lacteal secretion, practically free from colostrum, obtained by the complete milking of one or more healthy cows. Milk that is in the final package form for beverages use shall have been pasteurized or ultra-pasteurized and shall contain not less than 8 1/4% milk solid non-fat and not less than 3 1/4% milk fat. Milk may have been adjusted by separating part of the milk fat therefrom or by adding thereto cream, concentrated milk, dry whole milk, skim milk, concentrated skim milk, or non-fat dry milk, and milk may be homogenized. Now that's quite a definition, but essentially the requirements specify that it must be sourced from cows, and if packaged, it must have been pasteurized. There are minimum requirements for the amount of solids and milk fat in the milk, and the regulation also states that it is acceptable to adjust the components of milk to the desired specifications by separation or by addition of other milk components. In India, there is a definition for milk too, and the Food Safety and Standards Authority of India defines milk as a normal mammary secretion derived from complete milking of a healthy milch animal. It should be free from colostrum. Milk which is adjusted for milk fat or milk solid non-fat content of both may also be named milk, provided that the minimum and maximum limits for fat and solid non-fat are as per the standards of milk. Milk may be subjected to pasteurization, sterilization, ultra-high temperature sterilization, or boiling. And milk is further classified into species-identified milk, mixed milk, full cream milk, standardized milk, toned milk, double toned milk, or skim milk, with each having their own fat and solid non-fat content limits, which can also vary across states. So I would encourage all of you interested in this segment to also kind of go to the FSSAI's website and kind of just browse through the different standards of identities that they have around dairy products. Okay, so moving on to the nutrient aspect of legacy milk. Milk has a number of nutrients, including soluble components such as sugars and oligosaccharides. Lactose is an example of that, which are chains of sugars, as well as proteins and minerals such as calcium. The main types of proteins found in milk are the casein proteins at about 80% and the whey proteins at about 20%. Milk is very nutritious as it is basically a nutrient delivery system from the mother cow to her calf that provides the right mix of essential nutrients for the calf to grow and thrive. Milk also plays an important role in the development of the calf's immune system. The exact composition and nutrient makeup of raw milk will depend on a number of factors, including the species of the animal, the age of the animal's diet, and so forth. The components of milk not only provide nutrition, but they also provide functional properties to milk. For example, the fat in milk does more than just provide an essential nutrient. It also imparts a creamy texture and a rich dairy flavor to milk. Carbohydrates contribute to milk's texture and also impart a slightly sweet taste. Proteins are widely known as the most functional of all the nutrients. They provide various functional properties to milk like emulsification, gelation, etc. Milk protein's ability to emulsify helps to keep the fat droplets suspended in the aqueous phase rather than separating out, particularly after milk has been homogenized. The proteins in milk also have the ability to form a gel or to coagulate under certain conditions, which is essential for producing certain types of dairy products, such as gel dairy desserts, yogurts, cheese, etc. For vitamins and minerals present in milk, the most important function is the nutrition that they provide. So here we take a closer look at the nutrition of different types of processed milk, whole milk, low-fat milk, and fat-free milk sold in the United States. And again, we can take this reference and also extrapolate it to different countries. These are the different types of milks that have been adjusted again to meet the milk fat standards associated with the particular type of milk we are talking about. The label to your left shows the nutrition content of 1 cup of whole milk, which contains about 3.25% milk fat. You can see that the calcium level is high at 25% of the daily value, and it contains 8 grams of protein. But as you can see, the fat and calories are also high. The next label at the center is for low-fat milk, standardized to 1% milk fat, which is a popular low-calorie option for consumers. There is also a 2% version, which is called reduced fat milk, and that falls between the whole and low-fat milk in calories. Now, low-fat milk is usually the common choice due to its lower fat and calorie content for plant-based milk formulators, and you'll see that typically a lot of plant-based milks actually try to replicate the nutrition label of a low-fat milk. The last nutrition label shows fat-free milk, also called non-fat or skim milk, which contains no more than 0.2% milk fat, which rounds down to 0 on the nutrition label. And since fortification of milk is common, these labels all represent milks that have been fortified with vitamin D, which is a common practice as it helps improve calcium absorption. Now, continuing on the nutrition front, this slide shows a comparison of the quality of proteins present in legacy milk with those present in plants, and is an important factor to consider when formulating plant-based dairy products. The proteins that are found in milk are of high quality with the right balance of amino acids for the body. The two standard measures of protein quality are the PDCAS, which is an acronym for Protein Digestibility Corrected Amino Acid Score, and a newer method called the DIAS, which is an acronym for Digestible Indispensable Amino Acid Score. I would recommend everyone listening to this webinar to go through these methods at your own time, but the big idea over here is that both these methods compare the ratio of essential amino acids in the food to the ratio required by human body and their digestibility. A value of 100 or higher indicates that all the essential amino acids are present in food and that all of the protein in the food product is available for use by human body. As you can see, milk scores a value of greater than 100 on both PDCAS and DIAS, indicating that it is a high quality protein source. Soy has a DIAS score of 98 and a PDCAS score of 102, which indicates it is a high quality protein source too. Wheat, on the other hand, scores 54 on DIAS and 51 on PDCAS, indicating a rather low quality protein, which can mean lack of certain essential amino acids or low digestibility of the amino acids. For wheat, the amino acid lysine is in short supply and is referred to as the limiting amino acid. Protein quality is an important factor to consider when formulating plant-based dairy products and becomes especially important for certain types of products like infant formulas and sports nutrition products for athletes. A typical trick used by food scientists is to use plant proteins in combinations which complement each other's amino acid profiles and give a high protein quality score. Coming to the molecular structure of milk, milk is an oil and water emulsion with the fat globules dispersed in the aqueous phase of milk. The proteins in milk are either dispersed in aqueous phase or they are at the oil-water interface. There are two types of proteins in milk, whey proteins and casein proteins. Usually, casein proteins form what are known as casein micelles, which adhere themselves to the oil-water interface, and act as emulsifiers, in addition to lending a lot of other functional properties to the milk. Let's look at the structure in more detail now. Let's start off with the fat globules. As you can see, the fat globules in milk typically are in the form of a structure called native milk fat globules, which consist of triglycerides at the core. And then there is a complex tri-layer membrane around the core consisting of phospholipids, cholesterol, and proteins including casein micelles and glycoproteins. The hydrophobic core contains nutrients like non-polar carotenoids and vitamins. An interesting property of milk fat is that it is partially solid to solid at room temperature with a melting point of 37 degrees Celsius. And this melting property of milk fat lends itself to a lot of applications in milk-derived products. For example, a lot of products like butter, cheese are solid under refrigeration and partially solid at room temperature and melt when heated, which is one of their main functional properties. And this is one of the main challenges that plant-based dairy products are trying to solve for, which is melting. Milk fat's unique melt behavior, softening well at body temperature while retaining a solid texture during refrigeration, also allows for a slow release of flavor in various food products, leading to an enhanced flavor profile. The second thing to look at are the proteins found in milk, and let's focus on caseins here in the form of casein micelles. Casein micelles are natural nanoparticles composed of various kinds of flexible proteins, including alpha, beta, and kappa caseins, and minerals, calcium phosphate nanoclusters, which are held together mainly by hydrophobic and electrostatic forces. The biological function of casein micelles is to carry large amounts of insoluble calcium phosphate to mammalian young in liquid form and clot in the stomach for more efficient nutrition. Casein micelles have an interesting structure as they hold a lot of water, much higher in volume than volume of micelles themselves, and they do not aggregate or sediment, and along with other proteins, they coat the fat globules acting as emulsifiers. A lot of plant-based dairy research is focused on recreating milk structure using plant-based oils and proteins, and one of the methods which we'll be discussing later is focused on recreating the oil-protein-water interfacial structure. The hypothesis is that this structure will lead to similar functionality of plant-based dairy products as animal-based dairy products have. Okay, so the typical steps involved in processing legacy milk are shown on the screen. We first receive the raw milk from the dairy farm. We then subject it to a preheating and separation step, usually via centrifugation to obtain the fat component and fat depleted serum component. And these two fractions can then be recombined in various ratios to obtain skim milk, 1%, 2%, or whole milk, as well as different kinds of cream. The milk is then homogenized to reduce the fat droplet size and ensure effective coating of protein molecules to the surface, which prevents creaming over storage. The milk is then pasteurized, heat treated to inactivate the pathogens and reduce the bacterial load so that the milk retains quality and is safe to consume. The heat treatment can vary in temperature time conditions, which leads to the products of having varying shelf lives and storage conditions. It is then passed through a cooling stage and a packaging stage before heading out to the distribution channels. And the reason we are talking about this flowchart over here is that plant-based milks also have a similar processing flow. And usually milk processing facilities can also be used to process plant-based milks, undergoing like specific allergen cleaning protocols. And this is especially important for entrepreneurs who might not have the funding necessary to set up their own manufacturing facilities at the beginning. Legacy milk also has certain specifications when it comes to sensory attributes, nutrition, and applications. And for plant-based milk to be an effective replacer for legacy milk, it needs to hit most, if not all, of these parameters. Many consumers have grown up drinking legacy milk and are therefore familiar with its distinctive attributes. It is a low viscosity fluid with an optically opaque, creamy white appearance and characteristic bland flavor profile. It has quite a mild flavor and light color, which means that any off notes or any off colors are easily detected by consumers. This is one of the major challenges for many plant-based dairy products that come with characteristic flavors or pigments, such as almond, coconut, flaxseed, or oat sources. As explained earlier, milk also has a highly digestible and bioactive protein profile. It is also usually fortified with vitamins A and D, and a lot of people consume milk for the nutrition it provides. Hence, it is essential to incorporate these nutritional parameters into plant-based milk too. Thirdly, people will only switch from consuming legacy milk to plant-based milk if the latter functions in a similar manner, and this is especially important in a country like India. Milk is often drunk as a cold beverage, but at the same time, it is also used in various other ways. For instance, it can be added to tea, to coffee, and to other hot drinks. It can be used to prepare oat milk or cereals and can be included in sauces or soups or preparing baked goods or desserts, etc. Milk can also be converted into a variety of other dairy products, such as evaporated milk, heavy cream, whipped cream, ice cream, yogurt, butter, ghee, etc. And these dairy products can themselves be used as components of sauces, soups, baked goods, and desserts. Now, ideally, a plant-based milk should be able to replace legacy milk in all the three buckets mentioned above. But this is a scientifically challenging task, and a lot of research is going on around the globe to create such a product. Having said this, we do see a lot of great plant-based dairy products out in the market, hitting few of the requirements, if not all, like plant-based milks, which can be had as a cold beverage and added to cereals, to coffee, to tea, etc. But one may not be able to make cheese and yogurt from it. We also have standalone products like plant-based yogurts, plant-based cheeses, etc. Okay, so now moving on to the main part of the presentation, which is on plant-based milk. There are four primary sources of making plant-based milk. Firstly, legumes like soy and pea. Soy, as we all know, has been used for a long time now for making plant-based milk, and pea is an upcoming source. The legumes are also high in proteins, which is an advantage if the formulator decides to use these legumes. Grains are coming up in a big fashion when it comes to plant-based milk products. As mentioned earlier, oat milk has grown significantly over the last few years due to its excellent foaming and creamy properties. And traditionally, rice milk suffered from solubility issues, but over the past few years, significant technological advances have been made, which have resulted in seeing rice milks on the shelves too. Seeds are an interesting source as you can use not just the proteins, but also the oil present in them for formulating plant-based milk, leading to better cost economics. When it comes to nuts, almonds lead the way, but products are coming up which use cashews, peanuts, and coconuts as their base ingredient. There are also companies using blends of various crops to complement each other's functionalities and nutrient profiles. Now, a typical formulation for a plant-based milk consists of different categories of ingredients, and each ingredient has a specific function to play in the formulation. The legumes, the grains, the nut source, and essentially anything that you use which forms the base imparts viscosity, mouthfeel, and is also the source for the carbohydrates, proteins, and fats. The proteins contribute to the functionality of plant-based milk. Gums or hydrocolloids are usually added to impart viscosity and creamy mouthfeel, though they are generally not preferred for a clean label, and a lot of research is going on to find cleaner label alternatives to gums or hydrocolloids. Sugars can sometimes be added to increase viscosity and to also give a sometimes preferred slightly sweetish taste. Then there are two types of flavors that are typically used in plant-based milks. First type are masking flavors to mask the off notes, the beanie notes or planty notes from the plant source. And the second are flavors that boost the base flavor. Example, adding almond flavor to almond milk. Vitamin and mineral premixes are added for fortification purposes. Additionally, phospholipids like lecithin can be added to provide additional emulsification, which prevents separation of different phases over shelf life. Okay, now there are two standard approaches to make plant-based milk. This slide describes the first approach, where we work directly with whole legumes, grains, nuts, and seeds. And in this approach, the plant's natural oil bodies are kept intact and they play an important role in the structure of the product. Going through the processing flowchart, the base ingredient is taken and soaked to soften the plant tissue. It is then subjected to a grinding step to break the plant tissue, followed by a filtration step to remove the fibrous hull material, leaving behind just the proteins, the soluble sugars, and the oil bodies. These oil bodies consist of the fatty core surrounded by a layer of phospholipids and proteins, and therefore it has a similar composition and structure to the milk fat globule. An optional blanching step can be added at this stage to inactivate any endogenous enzymes present in plant materials. At this point, other functional ingredients like flavors, colors, preservatives, thickeners are added depending upon your product specifications. The mixture is then subjected to pasteurization to inactivate the spoilage and pathogenic bacteria, followed by a homogenization step to break down fat globules further and to allow the proteins to adsorb to the oil-water interface and form a stable emulsion. It is then followed by filling and packaging steps. Okay, so a few aspects to consider while formulating plant-based milks include the fact that the sensory attributes of plant-based milks may not necessarily resemble those of the equivalent products formed by legacy milk. And this is mainly because of different protein, carbohydrate, fat, and mineral profile found in legacy milk. When it comes to fat, though present in a similar structural format, those in plant-based milks are different types of fats compared to those in legacy animal-based milk. And this gives plant-based milk a different characteristic mouthfeel and flavor depending upon the plant source. But there are technologies out there to reduce this mouthfeel if it is something that is not desirable. Now, when it comes to proteins, legacy milk has high level of casein, which exists as fairly disordered flexible chains and lead to the formation of specific types of structures. On the other hand, the proteins in plant-based milks are tightly wrapped into compact globular structures, which form different structures when they associate with each other. And this is one of the reasons why soy, almond, or coconut yogurts may have slightly different texture than a conventional yogurt. It can also be challenging to create a plant-based cheese that matches conventional cheese. One reason is that cheese production involves complex biochemical reactions that break down proteins and fats into many different small aroma and taste molecules. And since the type of fats and the type of proteins present in plant-based milks are vastly different, this leads to a different aroma and taste molecule in the final product. The second approach is a way of making plant-based milks without the use of whole legumes, grains, nuts, or seeds. And it's based on making an emulsion out of water and a plant-based oil and reconstructing the fat globules from plant sources to replicate milk fat globules. The logic being, instead of using natural oil bodies present in plants to replace milk fat globules, it is possible to construct artificial fat globules using homogenization technology. When oil and water are homogenized together in the presence of an emulsifier, they can form an oil and water emulsion with many of the characteristics of legacy milk, such as appearance, viscosity, stability, mouthfeel, and flavor. Going through the flowchart now, the three key ingredients at the beginning of the process are oil, emulsifier, and water. A variety of different plant-based oils can be used to construct this kind of emulsion, including coconut, flaxseed, olives, soybeans, sunflower. And each of these oils vary in its molecular composition, the physicochemical properties, sensory attributes, and nutritional profile. And thus, it's essential to select an oil matching the desired product specifications. When it comes to emulsifiers, various types of plant-based emulsifiers are available to facilitate the formation and stability of oil and water emulsions, including plant-based proteins, phospholipids, and certain polysaccharides. The next important step to recreating the fat globules is homogenization, which reduces the oil droplet size and ensures that the emulsifier adheres to the oil-water interface, stabilizing the reconstructed fat globules. The next steps are adding functional ingredients like flavors, colors, stabilizers, thickeners, followed by thermal processing and then packaging, filling operations. Now, ingredients and processing methods impact the physicochemical characteristics and stability of plant-based milk as they affect the thermodynamic state of the food system, resulting in a change of pH, ionic balance, etc. And let's take pH as an example. A change in ingredients can cause a change in pH, which impacts the charge of the system and the associated attraction or repulsion forces between proteins, since proteins are charged molecules. As seen on the graph to the right for pea protein, where the pH of the system is changed, and as we approach the isoelectric point of plant proteins, which is between a pH of 4 and 5, the proteins start aggregating and dissociating from the oil-water interface, leading to unstable emulsion, which is depicted via increase in the size of fat globules. And at the same time, proteins can precipitate out, leading to sedimentation and a gritty mouthfeel. So the two unit operations I would like to focus on now in the processing of plant-based milks, as they play a critical role in the organoleptic properties and the and the stability of plant-based milks, are homogenization and pasteurization. Homogenization, by definition, is the process of making things uniform or similar. In the case of plant-based milks, it is the process of reducing the fat droplets to the same size. This increases the surface area of fat droplets and ensures that the emulsifier coats these fat droplets, ensuring their stability and preventing creaming and flocculation. There are numerous kinds of homogenizers, including high shear mixers, colloid mills, high pressure valve homogenizers, microfluidizers, and sonicators. The most common type of homogenizer is the high pressure valve homogenizer, where the liquid, in this case milk, is forced through a narrow gap at extremely high pressures, and this causes a high shear, a large pressure drop, and a cavitation in the liquid, all of which act to homogenize the sample. Each kind of homogenizer has its own advantages and disadvantages in terms of costs, maintenance requirements, scale-up potential, production rate, and ability to produce small droplets with a narrow particle size distribution. And stakeholders need to make the choice depending upon the product requirements and the available capital. Plant-based milks in the market are also subjected to a pasteurization step to inactivate spoilage and pathogenic bacteria. The shelf life and type of storage, that is ambient or refrigerated or frozen, depends upon the temperature time conditions used for pasteurization. And the pasteurization process that is used for plant-based milks is similar to the one used for legacy milk. Going through the types of pasteurization, a common industry standard in legacy milk is high temperature short time pasteurization, when milk is heated to 72 degrees Celsius for a minimum of 15 seconds. This gives the product a shelf life of 10 to 21 days when kept refrigerated under 7 degrees Celsius. This type of pasteurization is typically not used in plant-based milk as of now, as the industry is still novel in most geographies, and the products being launched in the space are aiming for a longer shelf life. However, you'll find that high temperature short time pasteurized milk are found in more local or small scale setups, or where plant-based milks have been around for a long time for traditional uses, for example in markets like Asia, specifically East Asia. The next pasteurization type is called ultra high temperature pasteurization, and in this, the milk is heated to 138 degrees Celsius for a minimum of 2 seconds. This gives the milk a shelf life of up to 90 days under refrigerated conditions. Lastly, there is aseptic ultra high temperature pasteurization, in which we apply the same temperature time conditions of 138 degrees Celsius for a minimum of 2 seconds, but we make sure that the packaging material is sterilized, typically with hydrogen peroxide, and the environmental conditions under which filling occurs is also sterile. This leads to the product being shelf stable for 6 months or more. Few points to remember as someone trying to figure out pasteurization for their product are: 1. What shelf life is needed for your product? If your product needs a shorter shelf life, then maybe a high temperature short time type pasteurization may be good enough. An advantage of this pasteurization type is that the temperature time conditions are relatively milder, and they would have a less impact on the plant protein stability. Secondly, does your product need refrigerated storage or ambient storage? Ambient storage can be beneficial if the temperature controlled supply chain cannot be guaranteed, but aseptic processing is typically much more expensive than the other two pasteurization types. An interesting point to note is that historically, plant-based milks saw a big spike in their sales as soon as they were moved from a shelf-stable retail space to the refrigerated retail space, that is when placed beside the animal legacy milk. And consumers connected with this plant-based milks much better when this happened. Another thing to consider is that shelf life is not just about pathogenic bacteria. Shelf life is also from an organoleptic or a sensory standpoint. So even if the product is safe for a given amount of time from a microbial standpoint, there could be a chance that it might not be acceptable from a sensory standpoint much sooner than that. And thus, both organoleptic shelf life and microbial shelf life need to be taken into consideration when determining the shelf life of the plant-based dairy product. Okay, so let's now look at a few of the products out there in the market globally. Ripple is one of the premier plant-based milk companies in the United States, and their flagship product, the Ripple milk, is what you can see on the screen. You can also see the ingredient label and the nutrition facts. There are 14 ingredients, including their patented Riptine pea protein. The nutrition is comparable to legacy milk in the protein content, but Ripple has about half of the fat and sugar and fewer calories and more calcium. Let's now look at the functionality of each ingredient. Ripple is using as its base a proprietary pea protein ingredient called Riptine and is often credited for putting yellow pea protein in the spotlight as an alternative legume source to soy for protein-rich plant-based beverages. Concerns about the allergies and genetic engineering associated with soy help pave the way for pea protein. Ripple uses natural flavors, sugars, and salt to achieve its flavor, as is a common standard in plant-based beverages. Functional ingredients include dipotassium phosphate as a buffer, lecithin to keep the oil from separating out, a blend of gums for the right texture and mouthfeel, and for ingredient suspension. Vitamins and minerals have also been added, as well as sunflower oil, which help impart a slightly creamy, fatty character, similar to traditional dairy milk. Now moving to yogurt, on the screen you will see the nutrition and ingredient information for plant-based yogurt made by Keitel, which is a company based out of United States again. There is a little less protein in this yogurt than in traditional yogurt, but the fiber is higher at 2 grams. Traditional yogurt has no fiber. Keitel yogurt has no cholesterol, which is another health benefit compared to traditional yogurt. And Keitel does have less calcium than traditional milk, but many plant-based yogurt companies fortify their products with calcium to levels similar to traditional yogurts. Looking at its ingredients now, both the proteins and fat found in Keitel come from almonds. Almond also contributes to product's flavor as the sugar and the acidity provided by the culture. Functional ingredients include a blend of 3 different gums to achieve the right thickness and creamy mouthfeel and to provide stability against syneresis. The water binding ability of gums allows the gums to perform all of these functions. Live active cultures are the bacterial cultures that were added to the almond milk to ferment it into yogurt. Okay, so let's look at Daya now, which is a popular plant-based cheese brand based out of Canada. And Daya is known for its superior melting properties, which are important in applications like pizzas. Some nutritional benefits are that the calories and fat in Daya cheddar-style shreds are lower than in traditional animal-based cheddar cheese shreds. However, the protein and calcium are also lower compared to traditional cheddar cheese shreds. And this is a good example of how each plant-based dairy company must prioritize the most important features of its products. For Daya, the sensory qualities, including the taste, the color, texture, and mouthfeel of the product, and the physical property of melting were the most important goals. And this has proven to be a successful strategy for Daya. Looking at the ingredients now, together, the proteins, carbohydrates, and fat ingredients make up the base of Daya cheese. Since Daya is committed to making allergen-free products, pea protein is used as the protein source versus soy, and tapioca flour is the flour source used versus wheat flour. The blend of fats with different fatty acid profiles and their specific proportions are key to achieving the good melting properties that Daya cheeses are known for. To match the flavor of cheese, this product uses salt and natural flavors, as well as yeast for the savory umami taste, and citric acid to mimic the lactic acid tartness of traditional cheeses. For functional ingredients, glycerine and xanthan gum help to create the right texture and also help stabilizing the product. The coloring used are annatto to impart a yellow color and titanium dioxide, which can be used to lighten the overall color and improve the opacity. Now, an emerging novel approach to formulating alternative dairy products is the use of cellular agriculture. In cellular agriculture, traditional dairy proteins such as whey and casein can be produced through a microbial fermentation process. The DNA that encodes for a specific animal protein, like whey protein, is introduced into microorganisms such as yeast, bacteria, or fungi, which are then allowed to grow and undergo fermentation. The protein they produce can then be isolated and purified. And although these products are produced using genetically modified organisms, the microbes that carry out fermentation, the final products themselves do not contain any GMOs because the microbes are removed from the final proteins. Perfect Day is a company based in the United States using this approach. Because they are combining proteins made from cellular agriculture with plant-based fats, plant-based carbohydrates, and other ingredients, the resulting dairy products are actually hybrid products rather than fully plant-based. Now let's shift the track a little and talk about the regulations around plant-based milk. The two geographies that we'll be focusing on in this presentation are US and Europe, and then we'll also be talking a little bit about India. Let's start off with the US. As we saw earlier, legacy milk has a standard of identity in the US, and in many other countries, standards of identities are basically definitions for foods, explaining what they must or what they must not contain. Part of that definition stipulates that milk must come from cows, and this can present a problem for plant-based milk companies during labeling if they cannot include the word milk or other legally defined dairy terms on their labels. In the US, what was happening was that there were a number of plant-based milks on the market with labels that included the word milk, such as soy milk, almond milk, etc., but the FDA was not taking any enforcement action to prohibit this. But not so long ago, the dairy industry addressed this issue, calling for government to take action. Since then, there has been a lot of legal back and forth on this issue at both federal and state levels. While things can change quickly in this arena, the status as of July 2020 was that US federal regulations are allowing the term milk and other dairy terms to be used by plant-based dairy products. In light of this, some states, and often states with the strongest legacy dairy industry, have worked to pass laws preventing the term milk from being used on plant-based dairy products in those states, on the grounds that they are misleading labels and that federal government prohibits such types of labels. But given plant-based milk labels do not constitute misleading, as explained in the later slides, we can expect a pushback from individual plant-based dairy companies to get milk or dairy terms back on their labels. It is also important to know that most of these laws are not yet in effect. For plant-based dairy entrepreneurs and investors, it's important to have a good understanding of labeling regulations that can impact plant-based dairy products labeling, including regulations for countries, states, provinces, and trade areas. Even though the dairy standards of identity exist, plant-based dairy can use dairy terms on their labels because they are appropriately qualified. Example, soy milk. The Good Food Institute filed a petition with the US FDA in 2017 to make the case that FDA should clarify that new foods can be named in a way that references traditional foods in a manner that's clear to consumers. Since today's consumers are not likely to think that a product with almond milk or coconut milk on the label contains cow's milk, banning conventional dairy terms from plant-based dairy labels is not needed to prevent misleading consumers. In fact, now that almond milk and coconut milk are so widespread, changing it to almond beverage and coconut beverage would likely confuse the consumers about what these products actually are. Also, there is a precedent for allowing manufacturers to use a modified version of the legal term. For example, gluten-free bread is permitted, although it doesn't conform to the legal definition of bread. Europe is more complicated regulatory landscape for plant-based dairy products due to the combination of the European Union regulations and the regulations of many individual countries, each with their own requirements on the use of traditional milk and on the plant-based milk and dairy terms. For example, while the terms milk, butter, and cheese cannot be used on plant-based dairy products in the EU, according to the European Court of Justice, there are 130 exceptions to this rule spread across 15 European languages and the historical usage of terms in these regional languages. And on the slide, we have listed out some resources that can be viewed to understand these regulations in more detail, and we'll also be sharing these resources separately after this webinar. Okay, so as seen around the globe, in India, we are seeing a huge growth in plant-based dairy segment too. We see plant-based dairy products currently in the market using traditional dairy terms or making slight modifications to the traditional dairy terms and still communicating that meaning. The regulations in India around plant-based dairy are still evolving, and we expect India to have similar regulations which are around the globe. So please reach out to us if you have a product that is already launched or close to launch, and we could discuss more on this aspect. Okay, so moving to the white space opportunities in developing plant-based dairy products. If you are a company looking to develop plant-based dairy products, on the screen are the people you might need to hire. If you're a student looking to work in the plant-based dairy industry, on the screen are the domains you would want to study or specialize in. Going from top to bottom, plant genetics. This domain works upstream of the value chain in developing crops with optimal nutrition content, functionality, etc., which can be used in plant-based dairy products. For example, can pea or oat protein be grown such that they have a higher emulsification potential or have all the 9 essential amino acids, etc., answering questions like these. Second, biochemistry. This domain also works upstream in determining specific processes to extract and analyze proteins from plants and to functionalize the proteins. All of this information can be used when formulating plant-based dairy products downstream. Which brings me to food science. Food scientists are trained to understand the chemistry, biology, and engineering of food and formulate the food from an ingredient and processing standpoint to match the desired requirements of texture, flavor, shelf life, and cost. Another skill set crucial to launching products in this segment is engineering. Typically, chemical engineers, mechanical engineers, industrial engineers are hired so that they can apply their skill set in scaling up of food products from a lab scale to pilot scale to finally commercial scale. Here is a slide on the typical equipment that might be needed to create plant-based dairy products. The list is designed just to give you an idea, but it can vary depending upon your specific product requirements. If you're developing just the final product, then the equipment that you will need will include mixers, heat exchangers for trialing pasteurization conditions, homogenizers, pH and ionic strength testers. You might need equipment to define your process limits or to determine your final product specifications. And these would include texture profile analysis, rheometer, viscometer, moisture analyzer, etc. If your product also contains a protein extraction step, then you might need equipment used to extract proteins too, like milling, centrifuge, filtration units, spray dryers, etc. And then analyze those proteins, like a calorimeter or protein content analyzer, etc. So finally, there is a lot to do in the field of plant-based dairy, and you can be any stakeholder and can get involved in this. So if you're a food and beverage manufacturer, you can consider adding plant-based dairy products to your portfolio or expanding and improving existing offerings, focusing on flavor and new plant proteins. If you are a potential entrepreneur, evaluate your interest and fit in this high growth area of plant-based dairy products. If you're an investor, assess market gaps in the plant-based dairy segment to identify high growth opportunities. If you are an ingredient and equipment supplier, reach out to plant-based dairy companies to better understand their needs and supply the right equipment. If you're a plant grower, reach out to ingredient suppliers to learn about their evolving need for plant-based ingredients. If you're a researcher, focus research efforts on improving ingredient functionality, formulation, or stability of plant-based dairy products. Students, consider studying food science, biochemistry, or engineering and interning or working for plant-based dairy companies in India and around the globe. And consumers, buy plant-based dairy products and request them if they are not available. So that brings us to the end of the presentation today, and I would like to thank all of you for joining us in this review of plant-based dairy. And I hope you have learned a lot of new and useful information. And if you have any questions, feel free to reach out to us. You have all our email IDs, and you're also on the GFI India community. These were the references used for this presentation, and we'll be launching a version of this presentation soon as an open access material. So you'll have access to this presentation, this recording, etc., and also the references. And thank you. And we can take any questions now.
Thank you so much for that, Siddharth. Your presentation was great. There's been a lot of interest from all of our attendees, and we have a number of questions both in the Q&A bar as well as questions that were sent across to us prior to the webinar. I think we'll just start off with some of the questions that have come in during the course of your webinar. So one question that has continually come up is what technologies can be used to eliminate the undesirable taste and odor from plant-based milk?
Yeah, so this is a very good question. I think there are various ways to approach it. Again, the best way to approach it is definitely if you try to eliminate these flavor components right from the raw material itself. And I would say that, typically it is the unsaturated fatty acids present in your base ingredient or the enzymes that contribute or eventually lead to development of these off flavors. So there are different ways to remove these fatty acids. Your fat extraction step before you make your protein isolate plays a key role in this. And secondly, also steps to inactivate enzymes in your base material. So those are few steps on the upstream. But then if you still have some residual flavor components in your final product, you can always work with a lot of flavor houses across the globe. There has been significant development over the last few years in the type of solutions what these flavor houses have. You can have flavors to mask all of each of this off note. So you can have a specific type of a flavor masker just to mask the beaniness component, or you can have a specific flavor component to mask the grassiness component. And flavor companies are great to work with. They usually also have different scales how they classify grassiness versus beaniness versus some other off note. So I would suggest all entrepreneurs and people working on it to use these two approaches.
Great, thank you so much, Siddharth. Another question that's come in a lot is a lot of the attendees are concerned about whether plant-based milk will ever be, will we be able to use plant-based milk within the Indian context? So for our milky teas and coffees, would plant-based milk be a suitable alternative to legacy milk? And if yes, what products should our attendees be looking at?
So I think there has been significant development, right? If you compare plant-based milks, which were in the market, say 5 or 10 years back, they were absolutely not functional. As soon as you added them to tea or coffee, they curdled and separated out. But a lot of improvement has been made in India and around the globe. And I think it's about identifying the right protein properties. So the protein property you're looking at over here is stability to pH change, and you can use different types of buffers so that your protein is stable to a change in pH as soon as you add it to a tea or coffee. Talking about specific companies, we had GoodMylk, which presented I think few weeks back on this webinar, and I personally love their cashew oat milk. I think it is great and it is functional.
Thank you, Siddharth. Now on the manufacturing side of things, there's a lot of questions coming in on the economics of plant-based dairy and plant-based milk. So on terms of the manufacturing side of things, what kind of technological improvements do we have to see within India, within the Indian context, for plant-based milk to achieve parity to traditional conventional legacy milk?
So I would say that few of the bottlenecks are availability of ingredients. A lot of times, if you want to get superior functional ingredients, you might typically have to export them. Though I know that there are a lot of players in India now who have developed or trying to develop these ingredients. So cost may be an issue, upfront, because your ingredients are costlier. And secondly, I think plant-based dairy is still coming up in India. I wouldn't think like manufacturing to be as much as an issue, because as I mentioned earlier, a lot of equipments that are needed to make plant-based milks are the equipments which are also used by legacy milk. So if the entrepreneurs or if the stakeholders can make those strategic partnerships with co-manufacturing facilities, and so they should be able to scale it up in an effective manner.
Thank you for that, Siddharth. Now on the more technical side, we have a question here on whether you have an opinion on which score to refer to between the IAAS and the PDCAAS scores, and why.
That's a good question. And there is an article by the World Health Organization, I believe, which says that, in a few years, we'll actually be moving to DAS, instead of PDCAS. PDCAS is a standard now, but we'll be moving to DAS in a few years. And the reason why it is going to take a few years to move to DAS is that they are still getting all the DAS scores of all our reference proteins, like you saw milk protein, whey protein, and other references. And DAS is considered superior because in DAS, again, I need to read up the exact definition, but here you are testing the digestibility of firstly individual amino acids versus the whole crude protein, as is done in PDCAS. And secondly, the digestibility is tested from your ileum instead of from the pieces.
Thank you, Siddharth. Now the next question again on a technical side is how can consumers, how can producers or entrepreneurs looking to enter the plant-based dairy market look at replicating the homogenization step in the lab at a small scale during the R&D process?
So I believe there are homogenizers available, lab scale homogenizers, and you can approach R&D consultancies or universities which have these homogenizers. So a lot of universities in India have homogenizers. NIFTM has one. Uh, so you could go there. You could trial out your homogenization conditions, and if you are getting the right type of product, you can then scale it up. Approach co-manufacturers, or if you can purchase your own homogenizer in your own manufacturing facility, you can go about it.
We've had another question that was submitted to us prior to the webinar on whether algae can be used to manufacture plant-based dairy alternatives or dairy alternatives to legacy milk, legacy dairy.
So algae is an interesting source, right? And on top of my head, I don't remember if any plant-based dairy company uses algae as its source. Usually, the restriction with algae comes with its color. It can be green or yellow and stuff like that. So I think there is still a lot of research happening in removing the color molecules. But I believe algae can be a source in plant-based milks, and primarily because algae proteins are leaf proteins versus all these plant proteins. What we are talking about are seed proteins. So seed proteins are globular proteins, whereas leaf proteins are not globular proteins. So they can have different functionalities, and there are companies around the globe exploring usage of algae in different types of products. And again, post this, in the notes, maybe we could share the link to these companies and research groups around the globe which are working on algae.
Great. Thank you, Siddharth. The next question, again, a question that we have received prior to the webinar, as well as a lot of questions that are coming in right now, particularly on the Indian consumer sort of adapting to the taste of the plant-based dairy sector. How far do you think we are in terms of global parity, and how long do you think it would take for us to reach there?
Yeah, that's an interesting question. I would believe that when it comes to parity, different regions, consumers from different regions have got different taste profiles. So what would be hugely successful in the United States may not be hugely successful in India. And I can just give you a small example, like, all these fruit at the bottom yogurts and sweet yogurts and stuff, they have been popular in the United States, but they may not be as popular in India, at least right now. Like India, there are a lot of like young people, who are adapting to Western cultures and stuff. And eventually within 15, 20 years, we might have that sort of taste profile too, but the taste profiles would be different. Does that answer your question, Nicole? So what I'm trying to get to is that, plant-based dairy companies in India would need to understand the taste profiles needed by the Indian consumer and develop products accordingly.
No, I completely agree. And internally at GFI India as well, for all the participants interested, we're in the process of creating a number of resources on consumer and market insights focused specifically on the Indian consumer. So I would request everyone to join the GFI Ideas community so you can get regular updates on these resources as well. So we've had a number of questions on the regulatory guidelines for plant-based dairy products in India, as well as regulatory guidelines, even curiosity about the definition of milk. So we have one question that's come in on why most of the regulatory guidelines in their definition make it mandatory for milk to be free from colostrum Could you please give us some ideas on why that is?
That's a good question. And is it okay if we get back on this question in the notes later? Because I personally, I don't remember it on top of my head. So I'd rather give a detailed, correct answer rather than saying something which I know but may not be technically complete.
No, that's completely fine. And I think our attendees would appreciate that as well. Again, just a reminder, we will be circulating the presentation that Siddharth made today, as well as a recording of the webinar and a notes document. So in the notes document, we'll capture all the questions that were asked during this Q&A session, as well as questions and answers that we will be getting back to you on. So thank you, Siddharth. We'll make sure to capture those in the notes document. A lot of questions now, again, on product stability and questions about, or concerns rather, whether that would require a lot of additives. So I think if you can give the attendees just a bit of insight on what that process would require, and yeah, just some insights on product stability and shelf life.
Yeah, so again, as I was mentioning earlier, right, when we are talking about product stability or shelf life, there are two aspects. One is from a microbial standpoint, and second is from an organoleptic standpoint. From a microbial standpoint, additives are added so that pathogenic bacteria or spoilage bacteria don't. Pathogenic bacteria shouldn't exist in the product, but even spoilage bacteria shouldn't grow over time. But there are technologies again like aseptic processing, ultra high temperature processing, etc. Or you could use what is called a hurdle approach, pasteurization plus high pressure processing, technologies like that, which would lead to increased shelf life without you adding any other additives or preservatives, etc. So that is one way on the microbial front to reduce the number of additives. Secondly, if you really understand the reason why additives are added, right? Sometimes you need to add gums or hydrocolloids so that the plant-based milk is viscous. It holds water well, and the solids don't separate out. But say if you can get plant proteins with good water holding capacity, for example, oat milk, right? Oat milk has got a really creamy texture and it imparts viscosity. So the gums and hydrocolloids used in oat milk are less when compared to any other milk. So there are ways to go around reducing the additives in it. And I would say focus on getting a very functional plant protein or your base material to begin with.
Thank you. And just a follow-on question from that. Does plant-based milk and milk products require the same type of pasteurization methods as legacy dairy? And if so, what about the nutritional value of these proteins, i.e. at high temperatures, do they denature?
Yeah, so it uses the same pasteurization temperature time conditions. And again, because the way pasteurization is really defined, right? Pasteurization for egg is different than pasteurization for milk is different for something else. Is you select a target microorganism and understand what temperature time you need to like inactivate that microorganism. And again, the target microorganism depends on where that particular product can be found and what it can be contaminated with. So I think there are regulations coming around pasteurization of plant-based milks too. But for now, the industry does use the regulations of legacy milk. And what was your second question, Nicole? You may be on mute, Nicole.
Yes, sorry. So the second part of that question is the nutritional value of proteins, and at high temperatures, do they denature?
Yeah, so at high temperatures, they definitely, denature. Plant proteins are susceptible to heat. And that is why you need to be careful in determining your pasteurization conditions as, you might have a perfectly good product at lab scale, you have just formulated it, but not pasteurized it. But now you go to a manufacturing facility and pasteurize it or, subject it to aseptic processing. And then you'll see that within 2 days, it's no longer fluid. Your milk, it has become like yogurt. So that can be an issue that you can find. And even the nutrition profile changes too. When it comes to pasteurization, I would be more worried about the vitamins present and if you have certain vitamins which are very heat unstable, and if you have a very high pasteurization condition, then it might actually lead to a decrease in your nutritional profile of the product. So a good strategy to use is always do your nutrition content post your pasteurization conditions and over time, again through your shelf life, to really understand how much vitamins are there in your product.
Thank you, Siddharth. We received another question specifically on the plant-based yogurt sector and manufacturing high-protein yogurts. What would be the challenges to something like that and potential solutions?
I would believe, high protein plant-based yogurt, the challenges would be again sensory issues. A lot of times proteins, they have this gritty, chalky sort of texture. Again, when it comes to like traditional animal proteins, they get dispersed easily. But with plant proteins, that is an issue. So I would be worried about, and especially now that it's high protein, it could be more of problem solving when it comes to that. And yeah, I think that's what I envision. But then again, like whoever's question is this, I would say these two reach out to us and we can actually sit together, understanding your specific problem and chalk out solutions, because that way it will probably help you more rather than giving a generalized answer right now.
Thank you, Siddharth. We have left, just again for all the attendees, in case you do have follow-on questions and you would like to have one-on-one discussions based on very specific questions, I have left my contact details in the webinar chat. You can shoot us an email and then I'll be sure to connect you with Siddharth. Finally, is that we're getting a lot of questions on just the market and the strategy for plant-based dairy sector in India. Some questions on plant-based milk desserts and whether that will follow a similar trend. I don't know whether you'd want to answer this question quite generally, just on what I think you have answered it in your presentation in terms of what the growth trends have been in the sector, but maybe if you want to touch upon it again very briefly on how you see not just plant-based milk, but in general, the segment of plant-based dairy growing globally as well as in India.
Yeah, so Nicole, again, as mentioned in the presentation, right? Globally, there has been a growth in plant-based dairy. People want products, which are good for them, good for the environment, which are transparent, which are free from adulteration, and plant-based dairy can offer all of this. And yeah, I mean, and a lot of times, like, and if you can really replicate the, what do you say, the taste of legacy animal products at a price of legacy animal products, and if they are easily accessible, I think the segment has a huge potential in India. One thing to remember is that, for a plant-based dairy product to be really successful in India, one can start off with the niche consumers and start off with, say, the food halls and nature's baskets, etc. But then eventually, if it wants to be really successful, it would have to reach, all the cities and, different kirana stores, and it needs to be available for everyone, basically. One of the reasons why milk is so popular and India is the biggest, producer, consumer of milk is because milk is literally everywhere. It's just not restricted to food halls and, places like these. So that is something plant-based companies need to take into account.
Great. Thank you, Siddharth. And I think with that, if you have any final thoughts that you'd like to share with all of the attendees, I think we take that as the end of our Q&A session.
Yeah, I would just like to say thank you everyone for attending this webinar and spending your Friday afternoon with us. And it's very encouraging to see such a huge interest in this segment. I know we have attendees in this webinar from India and also from outside India. So thank you. And again, we at GFI are here to accelerate the alternative protein ecosystem. Today's presentation was on plant-based dairy, but we also help accelerating plant-based eggs, plant-based meat, and in addition, products made using cellular agriculture and the cultivated meat products. So thank you again, and feel free to reach out to us for any queries or questions and follow-ups.
Thank you so much for that, Siddharth. And I'm echoing everything a lot of the chat that's being, a lot of the chats in the webinar chat box right now, and a lot of people appreciating how detailed your presentation was. And thank you so much for spending time with us and going through that with us.
Thank you, Nicole. It was a pleasure.
All right.